Dear students, we'll try to understand mixed strategy in game theory in this video. This mixed strategy is to allow the agents to randomize their strategies. That means we have to assign a probability to each choice and to play their choices according to those probabilities. For example, please look at the table. There are two players. One is row, another is column. So row may choose to play top 50% of the time and bottom 50% of the time, where column may choose to play left 50% of the time and right 50% of the time. So this kind of strategy is called a mixed strategy. If row and column follow the mixed strategy, then they have to play each of their choices half the time. Then they will have a probability of 1 by 4 of ending up in each of the 4 cells in the payoff matrix. Therefore, if you multiply this 1 by 4 or 0.25 probability to each of the payoff, then add it all, we'll get rows average payoff is 0. Like that, the columns average payoff will be 1 by 2, that is 0.5. So here point is that the Nash equilibrium is nothing but, we can say that in Nash equilibrium, or the Nash equilibrium is mixed strategy, which refers to an equilibrium in which each agent chooses the optimal frequency with which to play his strategy given the frequency choices of the other agent. So in this kind of a mixed strategy game, we are interested in looking for mixed strategy equilibria as well as pure strategy equilibria. So please look at the table. Let us assign R be the probability that row plays top and 1 minus R the probability that he plays bottom. Similarly, let column be the probability, let C be the probability that column plays left and 1 minus C the probability that column will play right. So and here assumption is that pure strategy occurs when both R and C equal to 0 or 1. Now, to understand this mixed strategy, let us focus on row's payoff, that is row's expected payoff, where he chooses probability R. Let us calculate row's expected payoff if he chooses probability R of playing top and column chooses probability C of playing left. So the strategy top left consisting the payoffs 2 1 will examine now. That is from here we can find row's expected payoff. So to calculate row's expected payoff, he has to choose probability R of playing top and column chooses probability of C of playing left. So look at the second table where 3 columns are mentioned, that is combination, probability, payoffs or payoff to row. So in combination, first combination, top left strategy, probability, two probabilities are multiplied. For top it is R, for left it is C. So the combination top left probabilities are C, and corresponding payoff to row is 2. Like that, bottom left strategy of or combination of bottom left strategy has probability 1 minus RC, where payoff to row is 0. Third combination is top right, where probability is R into 1 minus C, where payoff to row is 0. Fourth combination of strategy is bottom right. The concerned probability is 1 minus R into 1 minus C, where payoff to row is 1. So by looking at this combination probability and payoff to row table, we can calculate the rows total payoff. How to calculate it? Now we have to multiply payoff into we have to multiply payoff to the respective probability concerning the combination and add all the multiplication of payoff to probability. In other words, we have to multiply third column into second column and add it all together. Then we will get the rows payoff. That's why please look at the write up. Rows payoff is equal to 2 RC plus 1 minus R into 1 minus C, which is equal to after some simplification it will be equal to 3C minus 1 whole into R. Now let us think that rho contemplates increasing R by delta R. So in this case, delta payoff to rho is equal to 3C minus 1 into delta R. So this is the expression, that is 3C minus 1 whole into delta R is delta payoff to rho, and this expression will be positive only when in bracket 3C should be greater than 1, or if you divide 3 each side, C is greater than 1 by 3. So this expression or delta payoff to rho will be positive only when C is greater than 1 by 3. And this expression will be negative when 3C in bracket should be less than 1, or if you divide 3 both side, we'll get that C is less than 1 by 3. So when C is less than 1 by 3, this expression or delta payoff to rho will be negative. Next, rho will be happy with any value, that is R is in between 0 to 1 when C equal to 1 by 3. So depending upon the probability of choosing strategy from column side, rho will have the positive, negative or range between 0 to 1. Probability R will get the value of R. So depending upon the C, rho's probability to choose strategy value will come. So it may positive, it may negative, or it may be in between 0 to 1, depending upon whether C is greater than 1 by 3 or C is less than 1 by 3 or C equal to 1 by 3. So this is all about rho's payoff. Similarly, this combination probability payoff to column table can be formed, and accordingly columns payoff is equal to CR plus 2 into 1 minus C into 1 minus R. After simplification, it will become 3R minus 2 whole into C. Let us, there is a, let us think that column contemplates increasing C by delta C. So in this case, the delta payoff to column equal to 3R minus 2 whole into delta C. So this is the expression which gives delta payoff to column, and this expression depends upon the R, that is probability of choosing strategy from row. So this expression, that is columns delta payoff to columns 3R minus 2 into delta C, will be positive, or this expression will be positive only when 3R in the bracket should be greater than 2, or if we divide 3 each side, LHS and RHS, R will be greater than 2 by 3. So when R is greater than 2 by 3, this expression will be positive. Again, when R is less than 2 by 3, this expression will be negative. And when R will be equal to 2 by 3, then column will be happy with any value of C which will lie in between 0 to 1. So this is columns payoff. So both rows payoff and columns payoff will get this information we can use, or this information we can plot using this information as a best response curve for both row and column. Let us start with row. If column chooses 0, please look at the graph. If column chooses 0, row will want to make R as small as possible. This means when C is equal to 0, then R is equal to 0. This choice will continue as a best response for row till C is equal to 1 by 3. Again, at this point, any value of R between 0 and 1 is best response. So, the red curve is traced horizontally. For all C is greater than 1 by 3, the row's best response will be at R equal to 1. Therefore, row's red best response curve goes on vertically again. So, the row's best response curve is red one. Now, we will talk about column's response. If row chooses 0, column will want to make C as small as possible. This means where R is equal to 0, C is equal to 0. This choice will continue as a best response for columns till R is equal to 2 by 3. Again, at this point, any value of C between 0 and 1 is best response. So, the blue curve is traced vertically. For all C is greater than 2 by 3, the column's best response will be at C equal to 1. Therefore, the column's blue best response curve goes on horizontally again. So, the column's best response curve is blue 1. Hence, it is easy to observe that these two best response curves cross in three places. That is the points 0, 0, 2 by 3, 1 by 3 and 1, 1. Out of these 2 points, that is 0, 0 and 1, 1 are two pure strategies. So these points 0, 0 and 1, 1 are two pure strategies. Out of these three, another one is that is point, another one point where two best response curve intersect to each other. Another point one is 2 by 3 and 1 by 3, and this is the point where Nash equilibrium or Nash strategy happens, and hence Nash equilibrium occurs. So finally we can say that the Nash equilibrium uh, arises or Nash equilibrium establishes where these two best response curves intersect at a point 2 by 3 and 1 by 3 in this figure. So other 2 points like 0, 0, 1, 1 are pure strategies, whereas the uh, third point 2 by 3, 1 by 3 is the Nash strategy, and hence Nash equilibrium occurs at point 2 by 3 and 1 by 3. So this is all about mixed strategy. Thank you.